Hello and welcome to this lecture on slopes. Probably be a few on slope. All right, so some pretty pictures to start the day with. Um, so when you look at this picture here, you can see some landscape pictures that have some pretty steep slopes. Some of them have pretty steep slopes. For example, this one right there has a pretty steep slope, and then it's not as steep there. This one has a slope going that way. Um, I'd hate to be walking along any of these, probably fall down. Um, right there. Oh, this one looks terrible. It's interesting. When I look at these, for one thing, the slopes, there are different steepnesses, and also some of them are sloped downwards when I look at it from left to right, and some are sloped upwards when I look at it from left to right. So here's another one, slope right there. And one is sloped upwards when I look from left to right, right? So this is going up from left to right. This is going down from left to right, right? And then there's this pretty picture. This one seems pretty flat. This slope here seems pretty flat, right? I wouldn't say it has no slope, but it's flat because everything has slope. Um, it's just the slope happens to be flat. And this is an interesting picture also of something that's sloped, but this is terraced farming, as you probably know already. So there is the slope, but if you were a human, of course you couldn't climb up that straight line, so we do this terrace thing where you go this way and then you climb up and then you go this way and then you climb up and then you go this way and you climb up and so on and so forth. So that's kind of interesting, right? So a mathematician, when they look at this, um, they ask themselves simple questions like, well, how can I tell the slope that is going down from left to right from the slope that's going up from left to right? So is there a way in which I can somehow tell this? And the answer is yes. So the way mathematicians tell if something is going down or whether something is going up is by using positive and negative. So if you're going down from left to right, then it has negative slope. Okay, if it's going up from left to right, it has positive slope. Okay, we'll talk about the flat situation in a minute. And the next question is, so here we have just a grid, and let's see if I can draw a decent line. Okay, I'll use a straight edge. Let's see here if I can get this line drawn. Good enough for our purposes, I hope. All right, so here we have a slope, right? Imagine that this is a slope. I know it's not as pretty as these slopes, but you get the idea. So this one now, based on our conversation, we can say this one here is going up from left to right. So going up from left to right. So we know that the slope, we would say this as positive slope. Slope is positive. And just, ooh, you know what? I see a interesting little toy there. Maybe I can use that. No guarantees that the picture will be any useful. All right, so not bad. Not bad. Okay, so this one here, it's going down from left to right. So we know this one's going to have negative slope. Now the next question is, how do we give a grade to this slope? Meaning, how do we quantify the slope? So clearly, if you go back up to this one, this slope is not not steep, not as steep, not as steep. This one is super steep. They're both positive. They're both positive, but how do we tell that that's not as steep and this one is as steep? So clearly we can assign numbers to it, right? So I'm just going to make this up. We can assign the number 10 to this one, right? The slope score. Pretend that it's a slope score of 10. Then clearly, naturally, we would say this line here would have a smaller slope score, right? We could say it has a slope score of I don't know, 4. I don't want to say 5 because then that implies it's half the slope of the previous one. But 4 seems like a reasonable number. So the idea, so you can sort of assign both a positive and negativeness, which tells you which way it's sloping, and then you can give it a slope score, which tells you how steep it is. So this one here, it's pretty steep. The negative tells you that it's going down, but it should have a slope score that's greater than this, right? Maybe not as steep as this one, but I could say it's a -8, for instance. And this, oh my goodness, that's like straight up and down. That's also going to be negative, but I'm going to give it a slope score of like 100, right? So the negative tells me which way it's going, and the 100 tells me how steep it is. So this seems like pretty arbitrary ways in which we assign the slope score, but there's actually a way in which we do the slope, measure the slope. The slope is measured by sort of like this terracing idea here, by picking any point on the slope and picking another point on the slope. So I'm going to try to find one that's on a corner, right? It's easy if you have a corner. And then you do this terrace notion, meaning how many blocks does it take me to go this way and then that way in order to go from that point to that point, and that count is going to be my slope. So this number here, we can count the blocks, that's a 2, and that number there is also a 2. So that's called the rise, and this is called the run, right? And the slope is equal to the rise divided by the run. That's how the slope score is figured out. So in this particular problem, that would be 2 over 2, which is of course the fraction 1, or 1 over 1 if you want to talk about it. So does the same thing work for this problem, right? So here's the problem with drawing lines. You need to do this nicely from a picture, you need two things that cross nicely at nice coordinates. So I'm going to pick those two up, right? And again, first of all, I know that this is going to be a slope of this is going to have a negative slope. So the slope for this line I know is going to be negative. So there I'm going to put the negative, right? And I'm going to count blocks. So again, to go from this block to that block, my run, that's this part, the run is 3, and the rise is 2. So the slope is 2 over 3. Now 2 over 3, just the number 2 over 3 is not as big as 1, so you can clearly see that this one here is not as sloped, not as steep as this one there. The difference is that this is sloped down from left to right and this is sloped up from left to right, but clearly it's not as steep as the first one. So let's take a look at these three problems here, these three pictures here, to see if we can write down the characteristics of each of these, right? So this one here, we can say the slope is guaranteed to be positive. So let's call this A, let's call this B, let's call this C, right? And this one here, the slope is negative. This one here, the slope is positive again. And of the three slopes, if I'm going to estimate, I would say that the slope of B is the steepest, right? That slope B is steeper, so the slope score is going to be bigger than steeper than slope A, which is certainly steeper than, which is steeper than C, slope C. Or we could say slope B is bigger than slope A if we didn't care about the plus and the minus, is greater than slope C. Can we find these, right? Can we find, that's our guess. Let's start with slope B. Can we find this? So the key to finding the slope, of course, is to find two places where the graph nicely crosses at a grid point. Maybe I'll expand this so we can see the picture a little bit better. So I don't know, it appears that it'll cross right there, and it crosses right there. So the run is 2, and the rise, what is that? 1, 2, 3, 4, 5. So it seems like slope B is equal to negative 5/2. What about slope A? Let's take a look at slope A. So let's see here, slope A. So again, let's pick 2 points that intersect nicely on a corner. So I'm going to choose that one right there and that one right there. So the run is that, which is 2, and the rise is that, which is 3. So slope A is 3/2. And then slope C, let's see, slope C. So again, let's find 2 places that it crosses nicely. So one's there, one's there. And so you could have picked any points that catches your eye where it crosses. And see, these seem to jump out at me. So the run on this one would be 1, 2, 1, 2, 3, 4, 5, 6, and up 2. So that would be 1, 2, 3, 4, 5, 6. Just checking my work. And so slope C would be a run of 6 and a rise of 2, which is 1/3. So you remember, always reduce our fractions. And that is sort of what we expected, right? We knew slope B was going to be negative, right? Slope, we knew that. We expected that. We expected the slope value to be bigger, the biggest of them all, and 5 divided by 2 is 2.5, so this is the number, negative 2.5, and this is just 1.5, so we knew, we estimated that. And then 1/3, that was slope C, was the least, and we knew it was going to be positive. So there is that. Alright, so next up we'll take another look at how to find the slope using sort of the slope formula and explore parallel and perpendicular lines and so on and so forth.